world's deadliest supercarrier, completely defenseless, HMS Queen Elizabeth. This is the flagship of the Royal Navy. A 65,000-ton mountain of specialized steel, twin command structures, and cutting-edge stealth fighter jets. On paper, it is the premier tool of British global power projection, designed to signal unmatched maritime dominance across the world's oceans. But if a single modern anti-ship cruise missile breaches the outer escort screen, this multi-billion-pound capital ship is completely defenseless. It is an engineering contradiction that defies basic maritime logic and decades of established naval warfare doctrine. In the modern theater of high-intensity conflict, high-value assets are traditionally built with dense layers of independent, organic air defense. Yet, Britain's premier supercarrier sails into contested waters without a single long-range surface-to-air missile cell bolted to its deck. If the destroyers protecting it are forced to detach for secondary missions, or if their complex propulsion systems experience a mechanical failure in a high-threat combat zone, the crown jewel of the fleet becomes the largest, most expensive target in the water. This is the HMS Queen Elizabeth paradox. It is a story not of tactical oversight, but of systemic design compromises, inescapable budget traps, and architectural flaws that left the Royal Navy's ultimate weapon entirely reliant on outside help, just to survive. To understand how a major global superpower constructs an unarmed capital ship, you have to look beneath the flight deck at the financial wreckage of the Strategic Defense and Security Reviews. The story of the Queen Elizabeth class begins not in a naval design bureau, but in the highly politicized corridors of Whitehall, where grand geopolitical ambitions clashed directly with a severe structural lack of funding. When the project was conceived in the late 1990s under the Strategic Defense Review, the mandate was clear. The Royal Navy required an expeditionary carrier capability that could break away from the small, restrictive light carriers of the Invincible class. The new vessels needed to be massive, capable of generating sustained air sorties anywhere on the globe without relying on shore-based airfields. However, as the design phase progressed through the 2000s, the economic realities of megaproject procurement began to set in. The cost of raw materials, advanced electronics, and specialized labor began to skyrocket, threatening to spiral the project into a terminal budget deficit. The Ministry of Defense found itself trapped in an economic death spiral. By the time the landmark 2010 Strategic Defense and Security Review arrived, the carriers were facing a brutal binary choice: cancel the entire program at an astronomical cost in contractual penalties and domestic industrial damage, or strip the internal subsystems of the ships to the absolute bone to save the physical hulls. The Admiralty, desperate to preserve the foundational capability of a blue water navy, chose the hulls. They gambled on a philosophy of fitted for, but not with. A procurement euphemism meaning the structural space for weapons would be built into the ship, but the actual weapons, radars, and ammunition magazines would not be purchased or installed until a vague future date when budgets cleared. The first and most catastrophic casualty of this severe financial compromise was the ship's organic, independent survivability. When the blueprints were finalized, major weight allocations and electrical reserves that were originally intended for robust area defense missile systems were systematically deleted. The space where vertical launch cells should have sat was converted into storage or left completely empty. The priority was shifted entirely to maximizing flight deck square footage and aviation fuel capacity at the expense of defensive teeth. The ship emerged from the Rosyth shipyards as a massive, hyper-optimized airfield, but as a warship, it was fundamentally incomplete. The Royal Navy had gambled its entire strategic future on the assumption that it could always afford to build and deploy a flawless protective shield around its new centerpiece, leaving the carrier itself entirely dependent on its escort ships for every second of its operational life. A standard American supercarrier, such as a Nimitz or Gerald R. Ford-class vessel, is outfitted with a highly integrated, multi-layered defensive suite. These massive American hulls carry multiple octuple launchers for the NATO Sea Sparrow or Evolved Sea Sparrow missiles, ESSM, alongside dedicated rolling airframe missile, RAM, systems. These organic weapon systems allow an American carrier to actively participate in its own defense, intercepting incoming threats dozens of miles away from the hull. HMS Queen Elizabeth, by stark and jarring contrast, relies almost exclusively on just 3 phalanx radar-guided Gatling guns and a handful of small-caliber automated barrels scattered along its catwalks. To fully appreciate the severity of this tactical limitation, one must analyze the physical capabilities of these systems. The Phalanx Close-In Weapon System, CIWS, is an ultra-short-range terminal defense asset. It utilizes a 20mm Vulcan cannon designed to shred incoming projectiles via raw volume of fire. However, the Phalanx is not designed to stop missiles at a distance. It is a weapon of absolute last resort, engaging threats in the terrifying final seconds before impact. The operational range of a 20mm Phalanx system is severely limited, with an effective engagement envelope that closes rapidly within 1 to 2 nautical miles. This means that if the carrier is targeted by a modern anti-ship cruise missile, the ship cannot even attempt to engage the threat until the missile has already bypassed the entire outer perimeter of the task group and is mere seconds away from tearing through the hull. The architectural layout of HMS Queen Elizabeth completely lacks vertical launch system, VLS, cells. There are no Aster 15 or Aster 30 missile banks buried in the sponsons. There are no medium-range C-Scepter silos to provide local area denial. The ship possesses no independent radar architecture capable of directing mid-course guidance for complex surface-to-air missiles. This absence of organic weaponry has profound implications for the ship's internal layout and overall damage control philosophy. Because the carrier does not house its own defensive missiles, it lacks the heavily armored, specialized ammunition handling spaces and flash-proof tracking rooms required to support them. The ship was intentionally engineered as an incomplete puzzle piece. It cannot operate as an independent sovereign combat unit. It is structurally, mechanically, and doctrinally dependent on the task group around it to perform the basic function of staying afloat in a contested marine environment. The official naval doctrine protecting this design philosophy shields the vulnerability with a single, unyielding argument. The carrier never sails alone. Royal Navy leadership asserts that the lack of hull-mounted weapons is irrelevant because the vessel is permanently cocooned within the dense defensive envelope of a modern carrier strike group. At the center of this protective envelope sits the Type 45 Daring-class guided missile destroyer. The Type 45 is undeniably an exceptional air defense platform, engineered specifically around the Sea Viper system and the Samson Active electronically scanned array radar. A single Type 45 can track, target, and destroy hundreds of atmospheric threats simultaneously, providing a wide, highly sophisticated air defense umbrella over the entire fleet. But this heavy reliance on an external shield creates a catastrophic single point of failure within the UK's naval architecture. The fundamental problem is one of raw math and industrial capacity. The Royal Navy's surface fleet is notoriously small, heavily strained by constant global deployments, severe personnel shortages, and protracted maintenance backlogs. On paper, 6 Type 45 destroyers exist to shield the fleet. In reality, due to rotating maintenance cycles, deep refits, and unexpected equipment failures, the number of destroyers available for active deployment at any given moment is shockingly low, often dropping to just 2 or 3 operational hulls for the entire nation. Furthermore, the Type 45 destroyers themselves have suffered from a well-documented systemic engineering vulnerability. Their complex integrated electric propulsion systems, built around the advanced WR-21 gas turbines, suffered catastrophic design defects that caused them to unexpectedly lose all electrical power when operating in warm, tropical waters. During these propulsion casualties, the destroyer's main radars and missile systems would go completely dark, leaving the ship and whatever asset it was protecting suddenly blind and defenseless. While the ongoing Power Improvement Project, PIP, is working to replace these faulty diesel generators across the Type 45 fleet, the bottleneck remains acute. If a carrier strike group is deployed to a contested region and its primary air defense destroyer experiences a propulsion failure or is targeted and disabled by an enemy submarine, the defense umbrella over HMS Queen Elizabeth instantly collapses. Because the carrier does not possess organic, hull-mounted medium-range missiles like the Sea Scepter, it cannot absorb the defense responsibilities of a crippled escort. If the outer screen is breached or thinned out due to combat losses, the carrier cannot step in to plug the gap in the radar network. The multi-billion-pound flagship cannot protect the fleet because it lacks the basic engineering tools to protect itself. In the chilling reality of modern peer-to-peer maritime conflict, this complete lack of organic defense turns the carrier into an incredibly high-risk gamble. The era of low-intensity, asymmetric policing operations is over. Modern anti-ship doctrine practiced by top-tier adversaries relies heavily on the concept of saturation, the synchronized firing of dense, multi-vector salvos of supersonic and hypersonic missiles designed to completely overwhelm a target's radar processing capacity and exhaust its kinetic ammunition reserves. When a saturation attack is launched against a carrier strike group, the defensive escorts must achieve a mathematically perfect interception rate. Every single incoming missile must be tracked, engaged, and destroyed by the Type 45 destroyers and escort frigates. But if even 2 or 3 high-velocity tracking targets slip past the outer escort screen due to sensor fatigue, electronic jamming, or missile exhaustion, HMS Queen Elizabeth's terminal phalanx guns are immediately pushed to a catastrophic mathematical breaking point. Consider the mechanics of a modern supersonic anti-ship missile traveling at Mach 2.5. A weapon moving at this velocity travels at roughly 2,800 feet per second. By the time such a missile drops below the radar horizon and enters the phalanx's maximum effective engagement zone, the total reaction window for the automated Gatling gun is less than 4 seconds. In those 4 seconds, the phalanx must detect the target, spin its heavy barrels to maximum velocity, calculate a lead-angle solution, fire a burst of heavy tungsten ammunition, and physically shred the incoming missile's warhead. Even if the phalanx executes a flawless intercept at that extreme, close-in distance, the laws of physics dictate a terrifying outcome. Destroying a missile at a distance of 1,000 yards does not instantly vaporize its mass. The kinetic debris cloud, hundreds of gallons of unburned volatile jet fuel, and fragmented components of the heavy warhead will continue forward along their original trajectory at terminal velocity, slamming straight into the carrier's unarmored hull and flight deck. Because HMS Queen Elizabeth does not feature an armored flight deck on par with historic capital ships, relying instead on modern, structural steel optimized for aviation weight limits, this hypervelocity debris field would inflict catastrophic operational damage. Concussive shock waves would shatter delicate radar arrays, ignite highly volatile aviation fuel lines running beneath the catwalks, and decimate any F-35B stealth jets parked exposed on the deck, effectively neutralizing the carrier's offensive capability without the missile's main warhead ever needing to detonate. Ultimately, the physical architecture of the Queen Elizabeth class exposes a deep, unresolved tension between geopolitical prestige and raw engineering reality. The United Kingdom designed and constructed a world-class, technologically advanced aviation platform capable of projecting immense diplomatic and military influence across the globe. However, the nation failed to fund the fundamental, low-tech defensive infrastructure required to ensure that Hull could survive a modern, peer-to-peer sea battle. It is a warship designed around the best-case scenario, an asset optimized for power projection under the assumption that an ironclad, permanent defensive perimeter will always be provided by an underfunded, overstretched surface fleet. The empty spaces on the sponsons of HMS Queen Elizabeth stand as a stark, silent testament to decades of defense procurement compromises. The ship remains a triumph of British industrial engineering and an undeniably potent tool for launching state-of-the-art stealth aircraft. Yet, it sits in the water as a deeply fragile monument to budgetary trade-offs, a premier capital ship designed for the absolute highest levels of modern maritime combat, yet missing the very teeth required to guarantee its survival. The financial equations governing modern British defense policy mean that these empty spaces are unlikely to be filled anytime soon. Retrofitting the Queen Elizabeth class with a multi-cell vertical launch system would require more than just bolting missile silos to the deck. It would demand tearing into the ship's structural bulkheads, rerouting complex electrical trunks, and completely redesigning the internal magazine spaces to handle volatile rocket motor exhaust. For a Navy currently struggling to fund basic hull maintenance across its wider fleet, the cost of such an invasive structural overhaul is a fiscal impossibility. As a result, the ship's strategic posture remains locked into its original configuration. Every deployment into contested waters, whether transiting the Mediterranean, operating in the North Atlantic, or projecting power into the Indo-Pacific, is a high-stakes calculation of risk versus escort availability. The ship cannot simply slip away from its protective screen to conduct independent operations because an isolated carrier is a compromised carrier. This systemic vulnerability forces the Royal Navy into a rigid operational bottleneck. If a single Type 45 destroyer must leave the task group to refuel, escort a logistics vessel, or undergo emergency repairs, the strategic options available to the commander are instantly restricted. The fleet's flagship becomes an operational anchor, tying down valuable escort assets that could otherwise be used for wider maritime security, hunting adversarial submarines, or conducting independent surface warfare missions. This is the ultimate cost of the procurement choices made in Whitehall decades ago. By prioritizing the sheer physical size and prestige of a large flight deck over the low-tech necessity of independent survival, the UK created an asset that maximizes public impact but limits tactical flexibility. HMS Queen Elizabeth will continue to lead the fleet, sailing as a highly visible symbol of national capability and a powerful home for advanced stealth aviation. But beneath the polished exterior and the roaring jet engines lies a sobering reminder of modern military realities. In 21st century warfare, raw scale without organic protection is simply a multi-billion-pound target waiting for a catastrophic calculation error. If you want to unearth more engineering contradictions hidden within modern naval history, make sure to hit that subscribe button, drop a like on this video, and let me know your thoughts down in the comments below. What ship should we investigate next? Thanks for watching, and see you in the next deep dive.